Light means energy. But when we think of energy, we think of a lot of light, and a lot of fuel, and a lot of energy. Of course, you can't plug the sun into an electrical outlet, at least not directly. But new technologies like thin film solar cells, cellulosic ethanol, wind turbines, and biodiesel fuel from algae are essentially the next best thing to plugging directly into the sun. Capture the sun's power, and you've captured the essence of renewable energy. Today, most fuel comes from carbon sources deep inside the earth, like petroleum reserves. But the world's biggest fuel users can't get enough. Every day, it's harder and more expensive to move oil and gas around the world. Some big energy consumers have lots of coal. But burning coal fouls the atmosphere. Experts expect global energy demand to increase by at least 50% over the next 20 years. And carbon dioxide emissions could rise by more than 50%, trends that seriously threaten both the world's economy and its climate. In 2030, India will have 200 million cars, China 300 million. Both nations will be clamoring for more electricity too. And if it's all fossil fuel, vehicles, lights, cities, it will burn once and be gone forever. But we have options. What's more, many are renewable. No single energy source will solve everyone's energy needs. Solutions that work for one country don't necessarily work for another. Spain has solar. Denmark has wind. Brazil brews ethanol from sugarcane. But one thing is certain: prosperity requires energy. Today, 2 billion people in the poorest countries don't have adequate electricity or Blue regions here indicate places with plentiful electrical access. But elsewhere, electricity is harder to come by, and that means clean water, proper health care, education, and jobs are harder to find too. Some of Earth's poorest energy locations are actually energy rich in terms of their untapped potential. What we do is look for ways to transform that potential energy into practical, renewable energy. After all, we live on an energy planet. This might look like an ordinary stalk of graphite into energy and store it in their leaves and stems. Research, it might not be too long before you fill up trees with this. Because really, the fuel in those gas-powered cars is little more than pure sunlight. And that takes us back to the beginning. The ever-present sun leads the way. This is the age of transform how we harness and use energy for the future.
The ocean is constantly in motion. Thousands upon thousands of species living in a mosaic of habitats engage in a dance with our planet's changing chemistry and physics. With satellites, scientists can track changes in the ocean every second of every day. Change is nothing new. It's been part of life since life began. For all species, adapting to change is the key to survival. Many marine species spend their entire lives on the move, traveling thousands of miles every year from feeding grounds to breeding grounds and back again. These ancient routes are set by explosions of microscopic plants, triggered by annual changes in sunlight. Tiny animals called zooplankton feed on the plants. Sardines feast on the zooplankton. Albacore tuna feast on the sardines. And we feast on the tuna. Seafood is the main source of protein for more than 1 billion people. The natural rhythms of the ocean, its chemistry, and its biological responses are changing. We once thought that we'd never run out of fish in the sea, but now overharvesting is decimating many fish populations. Countless more animals are caught unintentionally and discarded, many to die. Some fishing techniques scour the seafloor, destroying habitat. Pollution is creating dead zones, where no fish can survive. And looming over all these daily assaults are long-term changes. Ocean temperatures are rising. Seawater is getting more acidic. Changes are happening so quickly that many species may not have enough time to adapt. But if we act now, we can give nature a chance to catch up, to adapt, to end bycatch. Citizens are pushing to reduce special places in the ocean for special protection. These marine protected areas, or MPAs, are safe havens for marine life, cultural artifacts, scientific research, and recreation. California is leading the way by creating an expansive network of MPAs along most of its 1,100-mile coast. Nature can catch up, but only if we help. For food, for our livelihoods, for a healthy planet, we need a healthy ocean. Each of us is called on to protect the ocean as if our life depends on it. Because it does.
Weather is the state of the atmosphere, to the degree that it is hot or cold, wet or dry, calm or windy, clear or cloudy. Climate is the sum total of weather for a given region, consisting of long-term averages of meteorological factors such as temperature, humidity, wind and precipitation, and also measures of their variability. Extreme weather includes unusual, severe, or unseasonal weather, weather at the extremes of the historical distribution, the range that has been observed in the past. While they occur only rarely at a given location, extreme weather events can have significant impacts, both positive and punishing impacts on society and on ecosystems. Extreme weather events should be expected. Globally, many occur every year, taking a huge toll and loss of life and property, often amounting to billions of dollars. The impacts of these events show that we are not well adapted to the present climate, and climate continues to change. Global climate is changing. The evidence is unequivocal. Glaciers are melting, Arctic sea ice is shrinking and thinning, mountain snow is less each year, water vapor in the atmosphere is increasing, and sea level is rising. The global warming of the past 50 years is due primarily to human activities. Will a warming Earth increase the frequency and intensity of extreme weather-related events? Today, science does not allow us to link each individual extreme weather-related event to a warming Earth, but most climate scientists agree that as the Earth warms, extreme weather events will increase. It's clear that heat waves and heavy rainfall events are happening more often and are increasing in intensity. And even in a warming world, there will always be cold events here and there, such as the severe winter of 2013-14 in parts of the United States. As the Earth warms in response to increases in heat-trapping gases, many other changes are occurring in Earth's climate system. The key to preparing for and coping with extreme weather events is improved weather forecasting. Early warning allows time to prepare for the event, boarding up windows if a hurricane is coming, using sandbags to prevent flooding, seeking refuge in a tornado shelter, and even evacuating at-risk areas. For nearly all extreme weather-related events, there is some warning. It may range from a few minutes in the case of some tornadoes to a few days or even longer for hurricanes. Our ability to forecast many extreme weather-related events has improved dramatically. We have more and better atmospheric data and more powerful computer models to rapidly analyze these data. Today, forecasts are more accurate and give earlier timelines. People living close to sea level will be at increased risk from hurricanes, typhoons, and nor'easters because the rising sea is topped with storm surges, adding to their destructive power from inundation and flooding. Given the impacts of extreme weather-related events and the probability they will increase in the future, a greater emphasis needs to be placed on anticipating and adapting to this increasing risk to reduce the impacts and to ensure communities' resilience, their ability to bounce back after an extreme event occurs. In addition to adapting to extreme weather events, we should reduce human activities that are contributing to global climate change, primarily the release of heat-trapping gases from the burning of fossil fuels. Stabilizing and then reducing atmospheric levels of greenhouse gases would limit the speed and magnitude of climate change and the probability of severe, pervasive, irreversible, and unmanageable damage to our civilization. Increasing the resilience of our communities, of our nation, and of our planet to all aspects of climate change, including extreme weather-related events, is perhaps the primary challenge for this generation. Stabilizing Earth's climate is a longer-term challenge. The longer we delay, the more challenging it becomes.